Here's the test bench of part 1 of the homework, and I designed the test bench as like at the beginning counter is enabled, and after 10 nanoseconds counter is turned off, and after 10 nanoseconds counter is enabled again, and after 10 nanoseconds the, this counter changes from the up counter to the down counter, and after 7 nanoseconds the counter is reset to 0. This is for make the counter not synchronize to the clock, and after 3 nanoseconds counter is set to the up counter and reset is set to be 0, and after 10 nanoseconds counter is counting up. And let's see the simulation. Like this shows this clock cycle, because counter is turned off, so the value keeps to be 1, and here the reset becomes 0, so the counter becomes 0, and here because counter the reverse is set to be 1, so the counter decrement by 1. And let's see the part 2. The part 2, my question is to implement a modern counter um, with using two processes. One is a free running counter, and the second is to check whether counter reaches the value which is n, and if it does, it will set a reset counter to 0. And let's run the simulation. Oh, by the way, in this case, the test bench is very simple, which is wait for some time. And this is simulation. Oh, you can see it's just a free running counter, and when it reaches 9, because I set uh, uh, n to be 10 and resets to 0 again,